Now we are going to see some trigonometry with non-right angle triangle. Let's consider this triangle. This triangle does not have any 90 degrees in any of the three angles. If I mark the angles as A, B and C, let me mark this as A, this as B and this as C. Then the sides opposite to angle A will be A, and the side opposite to angle C will be small c, and the side angle opposite to angle B will be small b. I need a right angle triangle to use the trigonometry. So I drop this perpendicular line here where this is 90 degrees. Now I have two triangles, say for example ABD and ADC. If I call this length as h and this as x, that is BD as x, then DC will be A minus x. So these are the two triangles we have with these sides xc and h here, and BH and A minus x here. If I use the right angle triangle ABD, then I can use Pythagoras theorem like this. C square, C is the hypotenuse of the triangle, so C square is equal to x square plus h square. If I use the other right angle triangle, which is ADC, then I have hypotenuse square, which is b square, is h square plus a minus x the whole square. If I expand this a minus x, then I get a square minus 2ax plus x square. Now h square plus x square by this is c square. Therefore I have c square plus a square minus 2ax. Now this x, where is it coming from? This is this part. If I use this triangle and this angle B, then I have cos B is equal to x over c. Therefore x is equal to c cos B. I can substitute this value of x here. C square plus a square minus 2a, and then x is c cos B. Therefore b square is equal to c square plus a square minus 2ac cos B is known as the cosine rule. We can shift the angles A, B, C in different forms. Say for example, this can be named as B, this can be named as A, and this can be named as C. So A, B, C's change. Then we can have other forms of this formula. We can start with C square. Then C square will be equal to A square plus B square minus 2AB cos C. So how exactly this cosine rule works? When you are using a side, one side b squared, say for example, equal to, then you use the other two sides c square plus a square minus 2ac. A and c are the same sides which you have used here, and cos of the angle here, which is opposite to this side b. So if I write c square equal to, then I start with other two sides a square and b square minus, I use the same sides 2ab, cos of the angle which is opposite to the side c. So if I start with a square, then my formula will be b square plus c square, that is the sides other than a are b and c, therefore b square plus c square minus 2 times b times c, the same sides we have taken here, and cos of the angle opposite to the side a, therefore this is cos a. Therefore these are the three cosine rules. Using this cosine rule, we can find the angles of the triangle. We can just rearrange their rule. Say for example, let me write the rule a square is equal to b square plus c square minus 2bc cos a. I can rearrange a, b, c and make cos a the subject of the formula. Cos a will be a square minus b square minus c square over minus 2bc. Or I can write it as b square plus c square minus a square over 2bc is equal to cos a. So the same way we can also find cos b and cos c. Cos b will be c square plus a square minus b square over 2ac, and cos c will be a square plus b square minus c square over 2ab. All these three formulas are derived from the cosine rule. Again, we are going to consider a non-right angle triangle. Let me name this triangle as A, B and C. Then this side becomes small a, this becomes small b and this becomes small c. If I have to find the area of this triangle, then I would write it as half base and height. Half times base times height is the area of a triangle. I have taken a as my base here. Therefore, it is half times base times, which is a here, and I need the height. So I'll write this as h here. Now, considering this h as part of this triangle, where the angle is b and here it is 90 degrees, then h can be written as c sine b, because sine b is h over c. Similarly, if I consider this triangle where the angle is c and the hypotenuse is b, then h can be written as b sine c. So if I substitute these two formulas in this, then I have area is equal to half a c sine b, or area is equal to half a b sine c. If I take off this a as base and I consider this b as my base, then I might get a is equal to half b c sine a. This can be easily checked. These are the three formulas for finding area of any non-right angle triangle. Let's continue further. We got an area of a triangle to be, let's say this is A, B and C, and this is A, B and C. So the area of the triangle, we had three different formulas for area of the triangle, which was half AB sine C, or half BC sine A, or half AC sine B. These are the three formulas we saw, which was for area of the triangle. Therefore, they are all the same as long as the triangle is the same. Now, if I divide all the three terms by half ABC, then I get divided by half ABC here, divided by half ABC here, and divided by half ABC. So I can cancel AB here, and I can cancel half BC here. I can cancel half AC here. Therefore, in this place I am left out with C here, A here and B here. So finally I am getting something like this: sine C over C equals sine A over A equals sine B over B. So it is known as sine rule. So what sine rule says is A over sine of this angle equal to B over sine of this angle equal to C over sine of this angle. This is what is known as sine rule. So far we have seen two rules, namely cosine and sine rule. Most of the time they are confusing. We will not know where to use cosine rule and where to use sine rule, because both the rules involve some angles and sides. Let's start with cosine rule. Cosine rule says, if I write one of the cosine rules, if this is A, this is B and this is C, in that case this should be A and this should be B and this should be C. Then the cosine rule says A square is equal to B square plus C square minus 2BC cos A. And we have two more, B square equal to 1, C square equal to. In all these three cases, we have three sides involved in it and one angle. So if we are given three sides and if you are asked to find one angle of the triangle, then we can use cosine rule. We can also use cosine rule if we are given two sides and one angle, but we are asked to find the other side, the third side. Then we can use cosine rule. If I am given two sides and one angle, then I can find the third side using cosine rule. This two side and one angle is a special case which we will be dealing soon. Let's consider the example here. Find the angles of the triangle of sides 12 centimeters, 13 centimeters and 11 centimeters. So say for example this is 12, this is 13 and this is 11. Since three sides are given and the angles are asked, then we can use cosine rule. Therefore, I can use the cosine rule. Say for example, I can start with 12 square. If I start with 12 square, then it should be the other two sides should be squared and added minus 2 times product of these two sides again. Maybe I can write it as multiplication times cos of the angle opposite to this side. So let me name this as angle x. So cos x. Then cos x will be equal to 11 square plus 13 square minus 12 square over 2 times 11 times 13. If I simplify this, I'll be getting this as 0.5105. So if I have cos x is equal to 0.5105, how do I find x? In your calculator, you will have a button which is cos inverse. This will be a shift of cos. So if I use x is equal to cos inverse of 0.5105 and I use my calculator for this, then I get the answer as x is equal to 59.3 degrees approximately. Therefore, this x is 59.3. I have found one angle when three sides are given. Let's move on to the next example. The next example has two sides and an angle, and we are supposed to find the third side. Let me read the question. If two sides of a triangle are 21 and 15 centimeters with an included angle 105, find the remaining sides of the triangle. So let me mark this as 21 centimeters and this as 15. Now, which angle is 105? So the word is included angle. So the included angle is very important. The angle should be included between these two sides, the given sides. So this angle should be 105. Since it's a rough sketch, it shows an acute angle. It is supposed to be an obtuse angle. So this is the given condition of the triangle, and we are supposed to find this side. So let me name this side as x. If I use the cosine rule, then x square is equal to square of these two sides minus 2 times the same sides and cos of the included angle, which is 105. If I simplify this, I am getting the answer as 829 approximately. Therefore, the side should be square root of 829, which is 28.8, again approximately. Therefore, this is another example which has two sides and one angle given, and you are asked to find the third side. Again, the angle included is a very important word in this examples. Let's continue and see where to use sine rules. So if I have a side like this, a triangle like this, say for example A, B and C, and therefore this is A, this is B and this is C. The sine rule says I can either write it as A sine A over A, or I can write it as A over sine A equal to B over sine B or equals C over sine C. So this is the sine rule. I can take two ratios at a time for solving problems. I can see that there are two sides involved, A and B, and two angles involved, the capital A and capital B. That is, we have two sides and two angles involved in a sine rule. Therefore, any three of them are given, I can find the fourth value. You should also see here an important point here. A over sine A equal to B over sine B equal to C over sine C. So if I'm considering these two ratios, then I'm using this side and this side. Whereas the angles used are either this angle or this angle and not the included angle C. Therefore, when the question deals with two sides and non-included angles, then we use the sine rule. Let's go for an example. Let me have this as 12 centimeters and this as 55 degrees and this as 40 degrees, and I'm asked to find what is this side. So you should check there are two angles on one side. Of course, we cannot use cosine rule. Cosine rule deals with only one angle. Therefore, this has to be obviously sine rule. So if I use sine rule, this over the opposite angle, therefore x over sine 55 equals 12 over sine 40. Which means that x is equal to 12 times sine 55 over sine 40. I can use the calculator and simplify this, and I approximately get this equal to 15 centimeters. So this is a very simple question where we can directly use the sine rule. Let me move on to the next example. If I am given as find the side A, given that angle A is equal to 63 degrees and angle B is equal to 49 degrees and B is equal to 18 centimeters. So again I have two angles given and one side given, and I am asked to find the third side. I can easily use the sine rule without even considering this triangle. I can just directly write the sine rule and substitute them. A is what we need, so it is sine 63 equal to B, which is 18 over sine 49. You can easily simplify this and get the angles of the side A easily. Rewrite this as A is equal to 18 times sine 63 over sine 49. I get the answer as 21.3 centimeters approximately again. So this is again another simple question involving sine rule. Let's have some more examples on sine rule. Side C is 10 centimeters, side A is 6 centimeters, and angle A is 35 degrees. Now if I draw the triangle, and if I name this as A, B and C, then this is side A, which is 6 centimeters, then this is side C, which is 10 centimeters, and this is side B, and angle A is given as 35 degrees. So I cannot use cosine rule here, because for very simple reason that this angle 35 degrees is not the included angle of side with 10 and 6 centimeters here. So the given sides do not include the angle given here. Therefore cosine rule is eliminated. We have to use sine rule here. The sine rule says A over sine A, and we are with C here, therefore C over sine C. If I use the answers, the values given for A and C and A, then this is 6 over sine 35 equals 10 over sine C. So sine C will be equal to 10 times sine 35 over 6. When I simplify this, I get that sine C is equal to 0.9559 approximately, and therefore C will be sine inverse of 0.9559, which gives me approximately 72.9 degrees. So if this is 72.9 degrees, then angle B would be 180 minus 35 plus 72.9, because the total angle of a triangle is 180 degrees. Therefore I'll be getting this as 72.1 degrees. I also have another possibility with angle C. I can also have angle C as 180 minus 72.9, which is actually equal to 107.1. If you use your calculator and find what is sine 10.1, it will give you 0.9559, which was the same thing as we got here. Therefore this is not the only answer. I have another answer, 107.1 for the angle. So I can have the triangle like this. The C is an obtuse angle now. This is 107.1 and this is angle 35. And how much will this angle be? This will be 180 minus 107.1 plus 35, which comes to be 37.9 degrees. So therefore there are two possible answers for angle C. One is 107.9, one is 72.9. Therefore this sine rule can give you two answers or two triangles with the given information here. The triangle either can be an acute triangle or it can be an obtuse angle triangle. Let's proceed further with one more example. Now I'm given A is equal to 14.6 and B is equal to 7.4, and I'm given angle B is equal to 65 degrees, and I'm supposed to find what is angle A. So if I draw the triangle, then if I name them A, B and C, then this is A, this is B and this is C. Therefore this is 14.6 and this is 17.4 and angle B is 65 degrees, and this is angle A. Again, we cannot use cosine rule because the angle given is not included between these two sides. Therefore, it is obviously sine rule. So 14.6 over sine A is equal to 17.4 over 65, sine 65, sorry. So in order to find angle A, I need to make the sine A the subject of this, and then sine A is equal to 14.6 times sine 65 over 17.4, which turns out to be 0.7605. Therefore, angle A will be sine inverse of 0.7605. Again, there is a possibility of having two angles. So the first angle will be 49.5. So this angle, the first angle here, will be 49.5. Now let me move on to the second possible angle of A, which is 180 minus 49.5, which is 130.5. So if I have angle A as 130.5 and angle B as 65, then angle A plus angle B will be 195.5, which is obviously greater than 180 degrees. Therefore, this is not possible because we have not included the angle C here. Without angle C, the angle of the triangle becomes more than 180 degrees, which is not possible. Therefore, this answer of angle A is not possible. In this case, we have only one answer, which is 49.5. Therefore, we have ambiguity in sine rule. Sine rule cannot be relied on completely. When two sides and a non-included angles are given, then we have to be very careful and we have to think twice before we give the answer.